Hello guys, so we have a question here on differential equations. The question reads, the differential equation x cubed plus 1 times d squared y on dx squared minus dx squared times dy by dx equal to 2 minus 4x cubed is solved subject to the boundary conditions y equal to 0, dy dx equal to 4 when x equal to 0. So these are our boundary conditions. By using the substitution u equal to dy on dx minus 2x, show that y is equal to x to the power 4 plus x squared plus 4x. So I'm going to be brief and detailed in this problem. So here we have a second order differential equation which is not homogeneous and it is not linear. Okay, so we need to actually use a substitution which has been given to us to be able to get the exact solution of the differential equation with respect to the boundary conditions given to us. So what we are going to do is that we are going to transform this differential equation in terms of y and x to a differential equation in terms of u and x. Then we try to see if we can easily solve it. Then we now get the values of y. Alright, so let's go. The video might be a little bit longer, but stick with me till the end. Alright, okay, so my boundary condition is that u is equal to dy dx minus 2x. So what I'm going to do is that I'm going to look for the squared y on the x squared. I'm also going to find dy dx all in terms of u and x, then replace back into the original differential equation. So I'm going to differentiate both sides of this differential equation. Okay, this u here is not a constant, it's a function of x. So if I differentiate it, I get du by dx. Now when I differentiate dy by dx with respect to x, I get d squared y by dx squared. Then when I differentiate 2x with respect to x, I get 2. Okay, so from this we can clearly see that d squared y on the x squared is just equal to du on the x plus 2. So that's what I'm going to replace here. Alright, so if I replace in the original differential equation, let us see what we obtain. So if you replace in the original differential equation, now also let us look for dy by dx. Alright, so let me find dy by dx. So from here, what is dy by dx? Dy by dx is just equal to u plus 2x. So I'm going to replace dy by dx with u plus 2x. Then I also replace the squared y by dx squared with du by dx plus 2. So when I replace, you realize that original differential equation, we are going to have x cubed plus 1 times the squared y by dx squared, which is du on dx plus 2, okay, minus 3x squared times, in the place of dy dx we replace it with u plus 2x. Then we equate everything to 2 minus 4x cubed. Now let us expand and see what we have. Okay, so if we expand, we have something like x cubed plus 1 times du by dx plus 2 times x cubed plus 1. Okay, I'm done with expanding the first man. Now let us expand this other man. We have minus 3x squared times u, then minus 6x cubed. Okay, so we are done expanding the second term. Now we equate everything to 2 minus 4x cubed. Alright, then let us try to see if we could send everything in terms of x to the right hand side. Alright, so if we do that, we are going to have x cubed plus 1 times du by dx. Okay, now this, I'm going to write this term. Okay, I'm going to write this term. So I'm going to put minus 3x squared times u. Now equal to, I'll start writing 2 minus 4x cubed. Then I'm going to add 6x cubed, so plus 6x cubed. Okay, then I am going to subtract this term. Alright, so I'm just going to subtract that term. Okay, so now I'm going to bring like terms together on the right hand side. So my left hand side remains intact. Okay, my left hand side remains intact. So here is my left hand side equal to, now in the right hand side, let us bring like terms together. So I'm going to expand the first part, which just stays as it is. Now the second part is 6x cubed, and the third part is minus 2x cubed minus 2x cubed minus 2. Now we see 2 minus 2 is 0. Okay, let me give it a different coloration. So 2 minus 2 is 0. Now next thing is that oh, sorry about that. Everything's supposed to be 14. Okay, now you see that 6x cubed minus 2x cubed is positive 4x cubed, then plus negative 4x cubed is 0. So at the end of the day, everything on the right hand side simplifies to 0. Alright, so we are going to have something like x cubed plus 1 times du by dx equal to, since everything on the right hand side here gives us 0, let's just send this portion to the right hand side. So when we send, we are going to have 3x squared times u. So this is now a first order differential equation in terms of u and x. We can easily separate variables and integrate, okay, so that we are going to find u in terms of x. Okay, so let us separate variables. So if we separate variables, you are going to have du over u equal to 3x squared divided by x cubed plus 1 dx. You see, this dx moves to the right hand side. Okay, the dx moves to the right hand side. Then we divide both sides by x cubed plus 1 and also divide both sides by u. We are going to have this at the end of the day. Now since I have separated variables, I can easily integrate. Alright, so let us integrate. So it means the integral of du on u is equal to the integral of 3x squared divided by x cubed plus 1 dx. Now if I integrate the left hand side, I just get the ln of the absolute value of u, okay, equal to, normally we need to add a constant of integration, maybe let me say c1, alright, because it is an indefinite integral. Now let us integrate the right hand side. You clearly see that if I differentiate the denominator x cubed plus 1, I get 3x squared. So it means that since the numerator is a derivative of the denominator, then the answer is just the ln of the absolute value of the denominator, then plus another constant of integration. Alright, that is the same thing I did on the left hand side. Since I know that if I differentiate u, I get du, that is why the answer is the ln of u. If I differentiate x cubed plus 1, I get 3x squared dx. That's why the result of the integral is just a ln of x cubed plus 1. Okay, now you realize that if I subtract c1 on both sides, I'm going to have here c2 minus c1. Okay, but c2 minus c1 is also a constant because c2 and c1 are all constants. So I'm going to just call that constant k. That is why in general we always just add the constant to one side of the equation. Alright, now we need to find the value of k. So we are going to use our initial conditions, that is our boundary values. So let's go back up. So these are the boundary values, boundary conditions. Here are the boundary conditions. So let me try to put them down here. So we have these for the boundary conditions, and then also we have, so you see that these boundary conditions are on y, on dy dx, and on x. But to get the value of k here, we need boundary conditions on x and on u. Okay, so we come back to our substitution, which says that u is equal to dy on dx minus 2x. Okay, so when these boundary conditions can be separated into two, which says that when x is equal to 0, we have that dy on dx is equal to 4. Okay, and then let me just go down. Let me just go to the next page. Okay, so we can separate these boundary conditions into two. When x is equal to 0, dy on dx is 4, and when x is equal to 0 still, we have that y is equal to 0. Okay, So since I have this, that u is equal to 0 on the x minus 2x, alright, so if we use this, we realize that we can now set a new boundary condition on u. So we can say when x is equal to 0, what is the value of u? Since u is equal to dy dx minus 2x, I'm going to replace dy dx with the value of dy dx when x is 0, which is 4. So I'm going to have 4 minus 2 times 0 for x, which gives me 4. Okay, so this is my new boundary condition, that is when x is equal to 0, u is equal to 4. So let me put it in red. So when x is equal to 0, I have that my u is equal to 4. Okay, when x is 0, u is 4. I'm going to use it to find the value of k. So let me copy back everything here and just proceed by finding the value of k. Alright, so to find the value of k, so this just means that I'm going to replace u with 4. Alright, so I'm going to have here ln 4 equal to replace x with 0, then I have k there. So from here, what is going to be k? K will be equal to, now everything here gives us 1, and the ln of 1 is 0, so everything here gives us 0. So k is equal to ln 4, alright, ln 4. And since 4 is positive, in fact, we are going to remove the absolute values because we have realized that when x is 0, u is 4 and u is positive. And when x is 0, x cubed plus 1 is also positive. So for us to have k to be equal to 4, we can just do without the absolute values. So it therefore means that we have that the ln of u, forget about the absolute value now, so the ln of u is equal to the ln of x cubed plus 1 plus the ln of 4. Alright, so let us get u. So from here, you realize that the ln of u is just equal to the ln of 4x cubed plus 4, because by the law of ln, if I also need to remove this absolute value from here, alright, by the law of lns, we need to multiply the argument, since the lns, we have both lns, so they have the same base, which is e, that's log to the base e. So just multiply 4 by each term here. So from here, you can realize that if you take e on both sides, your u will just be equal to 4x cubed plus 4. So we have gotten u. Remember, u was a function of x, so let me just call it u of x. Alright, so this is u. But the equation is asking us to find y, not u. Alright, so we come back again to our substitution, and our substitution is saying that u is equal to dy on dx minus 2x. Okay, so if we use this substitution, what does it mean? It just means that in the place of u, I replace it with 4x cubed plus 4. Alright, so u is 4x cubed plus 4. Then I equate it to dy on dx minus 2x. Then I try to find y. So I'm going to write dy on dx will be equal to what? 4x cubed plus 2x plus 4. Okay, then from here, this coloration is not good again. Let me try to put it in the dark coloration. From here now, I'm also going to separate variables and find y. So it just means that dy is equal to, we have 4x cubed plus 2x plus 4 dx. We now integrate both sides, alright, because you have separated variables. Integrate, we have integral of dy equal to integral of everything here. Alright, then if we integrate, like I said, we have indefinite integrals here, so we add the constant of integration just to one side. So if I integrate y, dy, I get y equal to, if I integrate 4x cubed, I get 4x to the power 4 over 4. If I integrate 2x, I get 2x squared over 2. If I integrate 4, I get 4x, then plus a constant of integration, maybe p. That's my constant of integration. Okay, so let me try to simplify each term. So y will give me x to the power 4 plus x squared plus 4x plus p. Now we need to find the value of p, so we still use our initial condition. When x equal to 0, y is equal to 0. Remember, we never use this initial condition. So we are going to use the initial condition when x is 0, y is 0. Alright, so what does this tells us? This tells us that 0 will be equal to 0 to the power 4 plus 0 to the power 2 plus 4 times, oh sorry, this is supposed to be yeah, it's 4x, right? Yeah, it's 4x, so it's 4 times 0 then plus p. All right, so from here we realize that p is just equal to 0. Okay, and if p is 0, we can conclude that therefore y is just equal to everything here except p, because p is 0. So that is the value of y. So let us run back and see if that is a proof. Exactly, so we got the final answer. Okay guys, if you love the video, make sure you like, share, and you subscribe to the channel. Turn on your notifications so that when subsequent videos are uploaded, you'll be notified to come and watch. Until then, stay blessed.